Today we're going to talk about calculating odds. The odds of an event A is the ratio of the probability that A will occur over the probability that A won't occur. And you can see that I've written this a couple ways. The first way was the odds of A, so I have P of A over P of A complement, so either the event occurring or not occurring. The odds against A, which means the likelihood that A will not occur, is the probability of A complement over the probability of A. It's important to pay attention to whether we're looking at the odds of A or the odds against A. So example 1, let's say I'm rolling a die. I want to find the odds of getting a 4. So we know that there is a 1 out of 6 chance that I'll get a 4, which means there's a 5 out of 6 chance that we won't get a 4. So you can see the odds of getting a 4, I have 1 over 6 over 5 over 6. Remember, when you divide by a fraction, you need to multiply by the reciprocal. So 1 over 6 times 6 over 5 would mean the 6's cancel out, and I get 1/5. Just a note, this is the same as the number of ways a 4 occurs divided the number of ways 4 does not occur. Also note, because this is odds, we don't write 1/5 as a percent. So you could have gone back to this problem and said the odds of getting a 4 would be 1 way to get a 4 over 5 ways not to get a 4. But period, stop right there. You don't write 20% because we're not doing probability here. So same thing, I'm going to look at the flipping a coin, and I want to find the odds of flipping a head. So the odds of getting ahead would be the probability of getting ahead over the probability of not getting ahead. Okay. So here, theoretically, the probability of getting ahead would be a half. The probability of not getting ahead would also be a half. A half over a half is 1. So we're going to write this as 1 to 1. You need to think of odds as being a comparison. So you don't want to reduce 1 over 1 to just the number 1, because then you wouldn't be comparing anything. So I want to say, when I'm thinking about getting the odds of getting ahead, I want to think for every 1 way to get ahead, there's 1 way not to. Again, this would be the same as the number of ways of getting ahead to the number of ways of not getting ahead. So 1 way to get ahead, 1 way to get something else. So it's still an odd, so I still leave it as a ratio. I also put in there this time with the colon in between to show you just a different way that you can write odds. All right. So let's find the odds of selecting a lollipop that is purple. So here, when you're looking at this, I can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9 lollipops. All right. This one in the center is purple. So I have 1 purple one, and I have 8 that are not. So 1 to 8 would be the odds of getting a purple. Let's say I find the probability of selecting a lollipop that is purple. Okay. And here I'm really trying to point out to you the difference between odds and probability. With odds, I go, how many ways can I get a purple one? How many ways can I get something else? With probability, I say, how many ways can I get a purple lollipop over how many lollipops are there in total? So 1 over 8 for odds, 1 over 9 for probability. Right. Here I moved over to a pie chart, and in the pie graph, it gives you the distribution of grades for a course. I want to find the odds of getting an A, the odds of getting a D or F, the odds of not getting a D or F, and then the odds of getting an A or a B. So let's start with getting an A. So I want to say there's a 25% chance of getting an A, which means there's a 75% chance of not getting an A. The two things together need to represent the whole. We can definitely reduce this. Both of those numbers are divisible by 25, which would be 1 to 3. And you are expected to reduce them if you can. The next one, a D or F. So I can see 15% says D or F, which means the other 25, 35, and 25 should add up to 85. So 15 to 85, which could be reduced to 3 to 17. Okay. The odds of not getting a D or F, you should really just flip it, right? if the odds of getting a D or F were 15 to 85, then the odds of not getting a D to F should be 85 to 15, or 17 to 3. They need to be just the opposite. The odds of getting an A or a B. So I can see A is 25%, B is 35%. So when you add that up, that's 60%, which means I have a remaining 40%. So 60 to 40 is the same thing as 3 to 2. Okay. We've seen how to go from probability to odds. Now I need to go from odds to probability. So I want to say if the odds of A occurring are A to B, then the probability of A occurring is A over A plus B. With probability, I need the denominator to represent all different things that can happen. So let's find the probability of rain, given the odds of rain are 3 to 1. And then we're going to find the odds of a candidate winning the election if I know they're 1 to 10. So let's look at the probability of winning if I know the odds. So let's go back to this rain one to start. If I know the odds of rain are 3 to 1, it means for every 3 ways it will rain, there's 1 way it won't. So that says I have 3 over 3 plus 1, so I have 3 over 4, or 75%. For the candidate winning the election, if it's 1 to 10, so for every 1 way they can win, there's 10 ways they won't, which means there's really 11 possible things that can happen. So 1 over 11 is 9.1%. Not too good. Alright, so let's do a U try. You select a card from the ones pictured on the left. So only from these. We're not going to a whole stack of cards. We're only dealing with the ones I put in the picture. I want you to find the odds of drawing a face card. And a face card would be a king, a jack, or a queen because there's actually a face on those cards. And ace doesn't have a face and 10 doesn't have a face. I want you to find the odds of drawing an ace. And then I want to know the odds against, notice that word against, drawing a queen. So try these and then come back and see how you did. Alright, so let's start with face card. There are 3 face cards, king, queen, and jack, and 2 that are not, so 3 to 2. Ace, there's 1, and there's 4 that are not. And then the odds against a queen, so this is not getting a queen. There are 4 things that are not a queen and 1 thing that is a queen. Okay. Here's another you try. The number of employees by gender and job status, full-time or part-time, is summarized in the table. I want you to use this information to answer the questions. So an employee is selected at random. Find the odds that the person is A, a woman, B, employed part-time, and then C, a woman employed full-time or a man employed part-time. So give yourself a minute to try these out and then come back and push play again and let's see how you did. Alright, so let's start with a woman. So I can look, there are 170 women, because you can read it right here, and there are 230 men. So the odds that a person is a woman would be 170 to 230. You could just drop the zeros, make that 17 to 23. Okay. Employed part-time. So here I can see 150 that are part-time, and then 250 that are full-time. So 150 to 250. You can reduce, yes, the zeros, but then also reduce by 5. So I divided both of them by 50, so I got 3 to 5. Then I said a woman employed full-time or a man employed part-time. So here's a woman employed full-time, there's 65, and then a man employed part-time was 45. So I want to add these two together. 45 and 65 should give me 110. And then compared to everybody that's left, which was 185 and 105, is 290. So 110 over 290 gives me 11 over 29. Just want to note that you need to be careful with the wording used in odds and probability. People often use them interchangeably, which is incorrect. Probability said as 1 in 4 means 1 over 4 or 25%. Odds said correctly would read 1 to 3 for the same data. I will be very clear when I ask you questions, but I want you to be aware of how numbers are represented in the real world. So, for example, the following information was gathered from the National Safety Council. All right, so here, where it says odds of death, and it's showing you how it's said, heart disease and cancer, 1 in 7, 1 in 27, 1 in 97, 1 in 103. Notice they use the word in even though they use the word odds. Same thing. Odds of winning the Powerball, so I'm just showing this over here with you, are 1 in 292,201,338, which is really, really small. So when you're comparing this, your odds of winning the Powerball, I just wanted to show you to comparing that to the odds of being struck by lightning, that this is much smaller, being bitten or struck by a dog, lethal execution, right? So when you're looking at these odds, these are pretty likely, having some of these up here at the top, especially, well, at the top as we get older. I hope that we're never having the problem that we're pedestrian incident, motorcycle rider incident, like those are bad. But we have certain things that are kind of unavoidable in life and other things that are more likely. And the odds of winning the Powerball jackpot, oh, I do wish you guys all luck, very, very unlikely. And just look at the difference between how odds are said and how percentages are read.